Hi guys, it's Mary McIntyre. Welcome back to my channel. The 12th of August is going to be a really special day. We've got two big events happening, so in this video I'm going to talk you through them. The first one is the partial solar eclipse, which is going to get about 90% obscuration of the sun. It varies across the UK, but it's around about 92%, so that's pretty awesome. And then that night is one of the nights of the peak of the Perseids Meteor Shower. So in this video I'm going to give you a guide to both of those events. Because this video will end up being long with covering both of them, I will put timestamps in the description box below. So if you just want to hear about one or the other of them, or you just want to hear about the meteor shower and how to photograph them, etc., I will put all the timestamps in the description box so that you don't have to sit through the whole video if you don't want to. So let's get started. I am going to first of all talk about a guide to the partial solar eclipse that's on the 12th of August. Then after that, we're going to go through the Perseids Meteor Shower and the outlook for this year. So first of all, the eclipse. We have a partial solar eclipse happening on the 12th of August. We are going to get around about 90-ish% obscuration depending on where you are in the UK. So if I use stellarium, you can see that this is what it looks like from where I am in Oxford, and you can see that the moon covers a pretty substantial amount of the sun. But don't forget, this is not a total eclipse, so you will not be able to view this through a telescope without proper filters. You won't be able to do photography directly of the sun without filters in place, so do keep that in mind. You are going to need filtration to observe it, but it's a pretty deep partial eclipse. It's happening near sunset, so I'm not sure whether we will detect any change in light level. It would be very difficult because it's sunset anyway. So the eclipse begins for me here in Oxford at 6:17 p.m. British Summer Time. That's UT or GMT +1 because we're on daylight time savings at the moment. So that is quite late in the day. So the sun at that time will be at around about 20 degrees. So it's still a decent amount above the horizon. So it's going to be really advisable to get somewhere that's got a good western view with nothing blocking the western horizon if possible. And you should have a really good chance of certainly seeing the beginning part of this eclipse. So as the eclipse progresses, we move along to maximum, which for me in Oxford is 91.8%, but at different parts of the UK, depending where you are, will get more obscuration. So we're actually going to be in Cornwall for the eclipse, and in Cornwall it's going to get to around about 95%, so just a little bit more than we'll get in the middle of the UK. The exact amount and stuff will really be determined by where you are latitude wise, so do check stellarium for your own location just to make absolutely sure that you don't miss the point of maximum. But for me in Oxford, the maximum is at 1913 BST, and that is when we are going to get nearly 92% obscuration if I was in Oxford observing it. And then the end point is at 2006. So when we're at maximum obscuration, the sun is just 11 degrees above the horizon, and when we get to the end, it's just 3.5 degrees above the horizon. So to catch the end point of the eclipse where the moon has fully moved away again, you are going to need somewhere that's got a really good view west. Otherwise, you are going to risk missing the very end of it. But it's a pretty awesome thing to be seeing as the sun is setting. Now, as I said, you will need filtration to observe this, but with one caveat: if there is cloud around, and I've deliberately not looked at any weather forecast yet for this, I don't want to jinx anything. So if you do have a lot of cloud around, you can sometimes see the sun through the cloud, and it's dimmed enough that you can actually look at it directly. So if it's cloudy, don't despair. It might actually help you if you don't have equipment to observe it with. So that's the timings for the eclipse. I'm going to talk about some safety things first. So never ever look through a telescope at the sun without proper solar filters in place. It will permanently damage your eyes, and there are no nerve endings in your eyes, so you won't even know that your retina is being burned or your cornea is being burned. The first you know about it is when you can't see anymore. So it's really not worth it. Just to demonstrate how strong the sun actually is, when I was imaging the sun one day many years ago, I was using my refractor and I'd put the end cap on the back of the finder scope, but the front one had fallen off, it hadn't gone on properly, and within a matter of seconds the sun had burnt a hole through that cap at the back. And that is a tiny finder scope that's about 1.5 centimeters. So you can imagine the power of the sun's rays through an actual telescope and eyepiece. It really just isn't worth the risk. So make sure you are using the correct filtration. So I am going to talk you through some of the equipment that will help to observe this, but do keep in mind that you need to keep your finder scope caps on at all times when you're observing the sun. So the easiest way to observe this is with Mark 1 eyeballs plus a pair of Eclipse glasses. So these are available to buy online, and there are lots of outreach astronomers that have them if they are local to you. So do check that out. There are quite a few of us that have bought lots of Eclipse glasses to try and help people that live nearby to see this eclipse. But you can get them online, so you only need one pair. Just make sure that you always put them on with your back to the sun, especially if you're going to let children use them. Back to the sun, put the glasses on, make sure they're properly on, and then turn towards the sun. It's actually really difficult to look at the sun directly with your naked eye because it just hurts too much, but always just be safe and make sure that you put them on facing away from the sun. So that's a really good way of observing it. And actually the lens on the Eclipse glasses is big enough that you can actually put it in front of the lens on your phone camera. So my phone camera is a Fairphone 4, it's 3.5 years old, and the camera on it is not the best. So, but this picture here is one that I took the other day. When the eclipse is happening, this is perfectly adequate enough that you will see the moon covering part of the sun's disk. So if your camera lens is very small, like you have on a phone camera, you can put the Eclipse glasses on the front, never the back of a camera, always on the front. Even a bridge camera lens or a compact camera lens might be small enough that you can do that, and that will allow you to directly take pictures of it through the Eclipse glasses. So that's really good fun thing to do. We did that in the USA in 2017. My stepkids were using Eclipse glasses and their bridge cameras to take photographs, and it worked really, really well. The other method, if you don't have any filters for your telescopes, is to use the projection method. This is where you cover your finder scopes, you point the telescope at the sun, and then have a white screen at the back of the eyepiece so that the sun is being projected. Now this does work really well, but there are quite a few caveats here, so just some safety stuff to be aware of. Projection is only suitable for small telescopes, and all of the components in a telescope must be glass. If you've got any plastic lenses in your eyepiece or at any point within your telescope, the lenses have to be glass. The plastic ones will melt. All the energy of the sun is coming in full force when you use the projection method, so you absolutely need to make sure that you don't have any plastic components that will melt and get destroyed. So that's the first thing to think about. It's also, if you've got a reflecting telescope and that's very large, it's not really suitable, because again, the telescope that's very big is going to intensify the sun's rays and it could overheat the piece of cardboard that you're pointing it at. So really a small refractor, medium refractor, or a small reflector projection will work, but you really don't want to overheat your mirror and risk the mirror in the telescope cracking. That would be a very expensive mistake, so don't do that. Projection is only suitable for short sessions, so don't leave it running for hours and hours and hours, because again, the heat can build up and we really don't want to damage our equipment. And if you are doing the projection method, never ever leave the telescope unattended. Particularly if you're doing a kind of outreach event with your neighbours coming to have a look, because people cannot resist looking into an eyepiece if they see a telescope. Even if it's inside a marquee with the caps on, people will still try and look through the eyepiece. So if you walk away and people don't realise that that sun is not filtered, they could look in that eyepiece and lose their eyesight within seconds. So never ever leave it unattended. If you're doing any kind of outreach events, have 2 of you and make sure somebody mans that telescope at all times, just to make sure nobody can accidentally look through it. And always keep both finder scope covers on, as I said. So projection does work. You can do it with binoculars, you can do it with small telescopes, but do keep these safety things in mind, because it's really important that you follow those. This is a small partial eclipse that we had last year, and this is the board that we had. It's a very Heath Robinson contraption that Mark knocked up. Worked an absolute dream. So we have a painted white piece of hardboard, and basically we could see the partial eclipse that way from the projection method with a small reflecting telescope. So that worked really, really well. So you can do that for this eclipse. You can also use the projection method with a colander. Anything that's got little round holes in it will project the eclipsed sun onto the ground or onto a piece of card. So you don't even need a telescope. You can do it with a pinhole camera, or you can do it with a colander, and that will work really, really well. Now, one thing that you can sometimes find very cheaply online are eyepiece solar filters. Do not, under any circumstances, trust those. Just don't do it. They're rubbish. They will potentially melt and damage your telescope or your eyes. So please don't use them. One thing you can use though are solar film filters. So these are certified solar film, and you can make them yourself, and I've got them for my cameras, and I've got a homemade one for my telescope. And with a refractor, if you've got an end cap like this that kind of is like an aperture stop, you only need the small part of it to be filtered. You don't need to filter the entire aperture. It'll work really well. So you can buy the sheets of Barda solar film. A4 size was around £20 last time I bought it, and then just make the filter to sit on the front of the telescope, making sure that it cannot under any circumstances fall off. When I do outreach events and I have this filter on my refractor, I duct tape that thing on so nobody can take it off. So just for safety reasons. So you can do your homemade ones. You can buy shop bought film filters, which are a lot less expensive than the glass ones. So we've got one for our 8-inch Ritchie-Chrétien telescope. So it's the same Barda solar film, but the advantage of these ones is you've got the plastic casing with the locking nuts on them, so you can tighten them up and it will grip the telescope and not blow off or fall off accidentally. So you can buy those fairly inexpensively. More expensive are the glass filters. There's not many companies that still make these now, but years ago, Mark bought a filter for our 70mm refractor for the Venus transit, and naturally it rained all day and we didn't get to see it at all. But this filter's been really good. It's a glass one, it's very good quality, it's a full aperture filter, and that works really well. So if you already have one of those, you can use that. The other thing that you can have, which is a bit more specialist and costs a couple of £100, is a Herschel wedge. Now this goes on the back of the telescope in place of your diagonal, and this filters all the sunlight down. Now Herschel wedges can only be used on a refractor. They cannot be used on a mirror telescope. So do keep that in mind. But you can pick the Altair ones up for a couple of £100, and the images with those are really, really good. Beautiful view visually, definitely higher resolution, better contrast, really, really good. And the photographs with it are absolutely fantastic. So that's really good as well. But we don't have a lot of time for this stuff to come now. So do keep in mind, if you need something like this, get it ordered really quickly, because the eclipse is only like a week and a half away. So we need it in time. The other thing you can use if you have one is a hydrogen alpha solar telescope. We've got a Coronado PST. It's about 18 years old now. She's a very old lady, but still performs fairly well, and you can get some great images with that. But you don't need a specialist H-alpha telescope to observe an eclipse. You can just do it by projection. Now, H-alpha telescopes are not the same as a hydrogen alpha deep sky filter, so please don't mix those two things up. I've had people write to me and say that they bought a hydrogen alpha filter and they were going to attempt to image the sun with it. Please don't ever do that. They are not the same thing. A hydrogen alpha solar telescope's got etalons in there. It's got energy rejection filtration. They are incredibly complex instruments inside. They've got tuning etalons, as I said, they've got energy rejection, they've got all sorts of different filters in there, and it is not the same as a little glass H-alpha filter for deep sky nebula pictures. So please don't mix those two things up. If you've got a H-alpha telescope, you'll know it's a specific instrument that can only be used for looking at the sun's chromosphere, but you don't need that. If you have it, it will be a good view.
to see. Now, in terms of photography, one of the easiest ways, if you do have a filter for your telescope, one of the easiest ways to take pictures is with a mobile phone. You can literally just hold the phone up to the eyepiece, use pro mode on your native camera app just to try and manage the focus a little bit better, stop it trying to autofocus and going a bit awry. I always use it in pro mode, then I can control the exposure and the focus and I get a better result that way. Now you can do that handheld. It's a bit of a skill to keep it still while you're trying to keep it lined up, or you can fairly inexpensively buy brackets that will fit over the eyepiece and you align the camera lens with the holes so that you get a way better result. So that works really, really well. This is a photograph that I took with our 70mm refractor and the glass solar filter that I showed you, and this was my Fairphone 4 photograph. I took a bunch of them and stacked them, but it just shows that even a phone that's not particularly good camera on it can still do a decent job. So if you can get pictures like this of sunspots, you'll certainly be able to get pictures of the eclipse with it, as long as your telescope is filtered. That's really important. Now, if you are taking pictures with a digital SLR and a zoom lens, you may not have a telescope, but if you've got time to make one of these filters and stick it on your zoom lens, you can very easily take pictures of the sun that way. The reason that I made mine this design that goes flat is because we needed to take it to the States with us. We were short on baggage space, and this folds very flat, and then those arms all come around the outside of the zoom lens, and then I hold them together with a tight Velcro strap. That's really good. It means we can store the filter flat on a bookshelf, so it's got no chance of getting damaged, and that works really, really well. So you can make one of those for a 300mm, 400mm, 500mm zoom lens, whatever zoom lens you have, and that will be fantastic for doing eclipse photography. So the kinds of settings that I would use would be something around about ISO 400 and 1/400th of a second, and this is the total eclipse done through a zoom lens. Obviously we're not going to get to totality this time, but this is a time lapse we created in America using just a zoom lens. I believe this was a 400mm focal length that he used, and you can do a time lapse and show the moon moving across, which is really cool. So even though we're not going to get totality like we did in that video, it's still a really fun thing to do if you do have a zoom lens, or just take a bunch of pictures at different times and make a collage. You don't have to make a video, but it's a really easy way. The sun is very bright even with that filter on, so ISO 400 usually plenty, but use the live view screen on the back just to get your exposures right, to make sure you're not overexposing. It really only needs a fraction of a second though. You really don't need a long exposure for the sun because he's very, very bright even through the filter. Now, if you have a digital SLR and a telescope, the way that you attach those two things together is using a T-ring and an extension tube. That goes on the back of the telescope in place of the diagonal. That's how we image, so it just goes straight through. Your telescope now becomes a zoom lens, and with the filtration on the front, whatever one you have, that particularly if it's on a tracking mount, that will keep the sun central, and then you can take pictures. So this was a digital SLR on the 70mm refractor, and this was ISO 400 and 1/2500th of a second, really very short exposures. And we did create a video of that partial eclipse using that setup, and you can see I had it programmed to automatically take photographs while we were dealing with an outreach event and showing people visually. So there are times where the pictures were taken where there was a lot of cloud passing through, but you can see that it still shows up even through the cloud. So this was like nowhere near as much obscuration as the eclipse that we're going to get on the 12th, but it was a really fun project to do, and I really enjoyed creating that video, and it looked really cool. So you can do that if you do have a telescope that allows you to put the camera on the back. Now, the best quality solar imaging that I personally get is with a little CMOS camera. You don't need this. You can do it with a phone if that's all you have. But if you do have a high frame rate CMOS camera like the ASI, that will basically take a short video and then you stack the really sharpest pictures within that, and it does a great job. So you can see on the left here, we've got a photograph of the sun that I took with the glass filter, and on the right hand with a digital SLR, and on the right hand side, it was the same setup, but I used the ASI camera, and you can see that it's got way more granulation, it's got better definition on the sunspots, everything about it is just crisper, and that's purely because it captures very fast video, so it will get an image that cuts through the seeing more frequently, so you do get a better result with it. But for an eclipse, you don't have to have that. But just to show you some other pictures, they are really beautiful with that. So that camera is amazing for the H-alpha telescope. That telescope is a nightmare to image with a digital SLR. I've done it for years. It's definitely a lot better if you use a CMOS camera on it, but you can just use your phone. As I said, you can hold your phone up and take some pictures and that will still work. So this is just showing you the H-alpha pictures, black and white and in false color. That is what you can get with those ASI cameras. This was the mono version that I imaged it with, and the detail was just extraordinary compared to what I was getting with the digital SLR. So absolutely brilliant camera. And this was some pictures with that setup that I took during the partial eclipse last year. So we didn't have a massive amount of obscuration, but it was still really cool to see, and everybody that came to watch actually really enjoyed seeing that in the garden. So that was really cool. Now, of course, more recently, we've got a market full of amazing smart telescopes. Some of them are now much more affordable than they used to be. We have the Dwarf Mini. I did a review of that on my channel a little while ago. We absolutely love this telescope. This comes with a magnetic solar filter. The sea stars all come with solar filters, and I believe the Vaonis Vesperas do. They all come with a solar filter, and they do a good job. The ones that come with the telescopes are not as good as the Barda aftermarket ones, which I haven't seen available yet for the Dwarf, but to be honest, we're happy with the pictures. So on the left is some pictures that we took. It's a photograph of the sun that we took with the Dwarf Mini. On the right is a quieter sun that I took with the C-Star S30 Pro, which has a much wider field of view, so the sun is much more cropped on the sensor. So actually the Dwarf gave us a sharper result, but again, for an eclipse, you're not looking at sunspots, you're looking at the moon obscuring the sun, and that is more than adequate to do that. So you can create a sequence of images with your smart scope and turn it into a video. So that would be really awesome. So if you don't have cameras, or you don't want to have a go at actually imaging, the other thing you can do is some sketching. So I did this from photographs, but there was a partial eclipse that we had quite a long time ago, 2021, and I actually did these drawings to show what it looked like when the moon was coming over the sun's surface. So that was really good fun. And another one that I did from a few years ago, based on a photograph by Stephen Helixer. This was a sun in H-alpha with a partial eclipse. For this event, I basically was dealing with a lot of cloud, and I couldn't set up anything automatic on the H-alpha telescope, and I was busy showing people the eclipse. It's one of those things, if you do outreach events, you are sacrificing your own imaging, and that's fine. I'm happy with that. I'd rather show a load of people in the village an eclipse who've never seen one before than have the best pictures for myself. But I didn't get a chance to image with my PST at all that day, but Stephen did, so I produced this drawing afterwards because I wanted to capture it with pastels. So that's all the gubbins about the eclipse. Hopefully there are some good tips there on imaging and imaging the sun in general. If you have any questions, pop them in the description box below and I will try to answer those in good time if I can. So let's move on to talk about the Perseids Meteor Shower. So after the eclipse, the sun is going to set pretty soon after the eclipse ends, and that will give you time to go and get some food, take your images off your memory cards, and then get ready, get your batteries charged again, ready to go out and observe the Perseids meteor shower. So the Perseids is one of the best meteor showers that we have through the year. So first of all, what is a meteor shower? Well, they're caused by debris left behind by comets or active asteroids. And what happens is that the comet comes in from the outer solar system. As it gets nearer the sun, the materials start to ablate off the surface. It forms a coma, it forms a dust tail, and it's leaving a trail of debris behind it. And it comes in the inner solar system, goes out again, and it will do that periodically and come back and replenish its own debris field. And then Earth passes through that debris field every year. And there are multiple meteor showers through the year, some major, some minor. This graphic is clearly not to scale, but it shows you that we do have this band of cometary dust that has been left behind, and Earth passing through that. And as those tiny particles of dust hit our atmosphere, they burn up and we get a streak of light in the form of a meteor. So meteors happen all the time, or every night. You will see at least 3 per hour that don't belong to a shower. A lot of those tend to be asteroidal fragments, but when we have a meteor shower, you end up with more meteors being present. So they are named after the constellation that the shower radiant lies. So the radiant is the point that if you see a meteor and you trace its path back, it will intersect where the radiant of the shower is. Now the meteor can be anywhere in the sky, but if its path brings it back to the radiant point, then it belongs to that shower. And the radiant is named for the constellation that it lies in. So for the Perseids, the radiant lies in Perseus most of the time, but not all of the time, which really brings me to a really important point, that radiants are not in a fixed position. So if you look through the activity period of the Perseids, I've created this graphic to show you that the thing in blue there, that's the radiant of the shower. It starts off right up on the top right side of Perseus, and by the end of the activity period, it's actually in Camelopardalis rather than Perseus. So do keep in mind that the radiant will change depending on the night that you're observing. But on the night of the 12th at 2300 BST, the radiant is 31 degrees above the northeastern horizon. So you can see it there off to the left shoulder of Perseus, kind of lying halfway between Perseus and Camelopardalis, but it is technically within the boundary of Perseus on that night. If we look at that later in the evening, it's risen up to 57 degrees above the horizon, which is good news for us. It means we get more meteors, and so that radiant is climbing higher and higher and higher, which contributes to the fact there are more meteors the later that you observe. So as I said, meteors belonging to a shower can appear absolutely anywhere in the sky. They do not only occur near the radiant, and in fact the radiant is not a good place to look at them. If you look at this is an all sky projection of all the Perseids that our meteor cameras caught in 2023. You can see where the meteors all seem to originate. The other lines, the dotted lines, are aircraft that happen to be in the shot at the same time, or bright satellites. So near the radiant, the trails are very short and they're often quite faint, but the further away from the radiant you go, you can see that the meteors have longer tracks, and all the really bright ones are actually quite far away from the radiant, and you just get a better result if you look a little bit away from the radiant. So even if you don't know your constellations particularly well in the summer sky, just know that the radiant for the Perseids is in the northeast. It's a number of degrees above the horizon, getting higher as the night goes on. So just look away from that, and then you'll get a better result. You'll get far nicer meteors. So the Perseids shower is already active. We've already been capturing lots of meteors on our meteor cameras. It's active from the 17th of July to the 24th of August, and the peak is around about the 12th or the 13th of August. Now the Perseids is an old shower. The debris stream is very spread out. It also has little arms of extra material that are little outliers. So sometimes we get a double peak. Sometimes you can get a peak a day early or a day late. So even though the peak is technically overnight 12th, 13th, it's worth observing the Perseids like a few days before and after that. While the rates won't be as high, you do still get some really nice meteors on the nights either side, and I actually image pretty much every night for the whole week when I'm doing Perseids photography. So yeah, I take loads and loads of pictures every night during the week of the peak, and it's really good. Now, the zenith hourly rate of the Perseids is second to top in the meteor shower calendar, and the zenith hourly rate is 150 meteors per hour. The press love to quote that number and then add a few on for good measure, just for the clickbait headline. You will not see 150 meteors per hour. The zenith hourly rate is not the rate of meteors that you are likely to see. So what is the ZHR? It's basically a theoretical number, and it's the number of meteors per hour, and it's assuming that the radiant is directly overhead, because if you imagine the radiant is by the horizon, half of the sky that it's producing meteors in is under the horizon for you. But if it's directly overhead, then all the meteors originating from there are filling your entire sky. There are no meteor showers where the radiant is up that high, never. You also assuming here that you are looking at the whole sky, and with the best will in the world, you can probably see a third. If you defocus your eyes and just let them relax, your field of view may well cover about a third of the sky. Also, it's assuming zero light pollution and no moonlight. Now, this year we have no moonlight because obviously we've just had a solar eclipse, which means there's a new moon. So it's fantastic conditions because there's no moonlight. But light pollution is a big problem for most of us in the UK and elsewhere. So it assumes no light pollution whatsoever. It assumes perfect sky conditions, as in no humidity, no other residual light pollution from anything. And it assumes that you have 20/20 vision. And as you get older, your vision will become impaired. So this is also looking at stuff that is above mag +6. Now, I've observed meteor showers for years, and I can categorically tell you that I have never seen a meteor that faint. My eyes just can't see them. So all of those numbers, if you assume all of those things, you get the zenith hourly rate, but that is just not what you are likely to see on any meteor shower. If you've got a zenith hourly rate of about 50 and you've got a new moon, the visual rate is going to be somewhere between 25 and 60 per hour. But remember, meteors are entirely random. You can't say exactly when and where and how many. So you may get a period of 10 minutes with no meteors at all. Then the next thing you know, there are 20 all in a really short time. So they are a random thing that you can't predict. So the press are going to go mad again with you're going to see 1,000 meteors per hour. It's just not true. You're likely to see somewhere between 30 and 60 if you've got dark skies and you've got good eyes and your eyes are fully dark adapted. Also very important. So, some tips for visual meteor observing. It's really important that you support your neck, because if you're looking up for long periods of time, your neck is going to get fatigued very quickly and you're going to pull all the muscles. So lie on a sun lounger. It's a really good reclining sun lounger, gives you the perfect angle to have a supported neck. Keep a blanket nearby, because even in August it can get very chilly once you get past midnight and the dew starts to form. Shield yourself from street lights if you do have a street with them. So even if you're just at the back of your house and sitting somewhere where your house blocks the street light, that will make a huge difference to how much you can see. Let your eyes get dark adapted, which means no phone. Like, don't keep looking at your phone screen to tweet or tell people what you've seen or what you haven't seen. You've got to let your eyes be used to the dark, and that takes at least 20 minutes. So if you're new to this and you go outside and you're not seeing much, just be patient, sit and wait. And after about 10 minutes, you'll start to see things that you couldn't see when you first went out. Always look in the direction that's got the darkest sky, but try to be at least 40 degrees away from the radiant, because you'll get a better experience if that is possible. But really, the important thing is to look in the darkest section of sky that you have, because that will give you the best chance of seeing meteors. So you can see that, again, if you're observing and you're looking at the radiant in the center of this picture, you're not going to have as good an experience as you will if you're looking further away. So do keep that in mind, and just try to let your eyes relax and just see what you see. The other thing is to keep a notepad and pencil handy. So the way that we do this is to have a pad, and we use our church clock tower in the village. We start at 11 normally. We will normally sit side by side but facing opposite directions, so we've got more sky coverage between us. Every time we see a meteor, we put a line on the pad. If at all possible, have a look and just check, does it intersect with the radiant if we follow the path back, just so you know it's a Perseid. What we tend to do is just put a dash in pencil on the page if it's a Perseid. If it's a sporadic, I just write an S. The Kappa Cygnids is also active at this time, so if it's a Kappa Cygnid, I'll write a K. And then keep doing that for the hour. Once the church clock chimes, turn the page, the same again for the next hour. At no point am I looking at the pad. It's dark. I'm using a pencil and I'm just randomly putting a blob on there, and then I count them all up when I go inside later. So that's all the record keeping that I do. It's really simple. It doesn't involve putting a torch on, and it's just a really cool way of capturing data without kind of having to write loads of stuff down and end up missing the next meteor because you're busy writing stuff on your pad. Now, the Kappa Cygnids are also active, and they are a good prolific producer of fireballs, so you do often get very bright Kappa Cygnids at this time of the year. But as well as that, you will get around about 3 sporadic meteors per hour, so do try to just differentiate them if you can. Not every meteor you see will be a Perseid, so do remember that. That's quite important. And just keep a special note of a fireball. Now, officially, a fireball is a meteor that's brighter than mag minus 4.5. No, it's not. Brighter than mag minus 4. So anything that is around the brightness of Venus, then that is classed as a fireball, and it's just a bigger chunk of comet dust that is just burned up. So do keep a special note of those. Note the time and the direction that you saw it in, and remember that if you are reporting this stuff, if you do see a fireball, meteors are burning up about 60 kilometers, 40 to 60 kilometers above your head. If a meteor is in your northern sky and you're in Oxford, if somebody saw the same meteor from, say, Cumbria, it will be in their southern sky. So if you are reporting a fireball, don't say it travelled over my house towards the ground, because we need to know where your house is, what direction to the ground it was going, and then we can figure out whether it was seen on meteor cameras from elsewhere around it. So it will not be in the same part of the sky if you live in different parts of the country, even if you've seen the same fireball. So it's really important to know the direction you was looking, but importantly where you saw it from, because it's no good saying you saw it going down towards the south if you don't tell us where you are in the country. So it's really important that you do that if you are reporting fireballs. So be patient. As I said, sometimes you'll see nothing for ages and then suddenly loads of meteors happen at once. But one thing that's for sure, rates will always increase when the radiant is higher, which happens after midnight. But additionally, after midnight, which is local time midnight, is 1 a.m. BST. And that is because the dawn side of Earth is facing the debris stream. So it's like running face first into a rain shower. More of the raindrops hit your face. And the same thing happens with the meteor dust. So when Earth's dawn side is facing the debris stream, that is when we get loads and loads of meteors. So the rate is notably higher once we get past midnight every time. And when you get past 1 a.m. and then past 2, the rates just keep climbing. So it's definitely worth observing before dawn. So it would be a late night, but definitely worth it. Now, this graphic does the rounds before every meteor shower, and it drives me slightly insane because it is completely false. Meteors are not fireworks. They do contain volatile compounds, and most meteors to the naked eye are visually completely colourless. And meteor spectroscopy is really very, very difficult to do. You have to have a diffraction grating in place, and then you've got to do all of the proper calibrations and all of that kind of thing. And if you do have a diffraction grating in place on a meteor camera and you do start to see peaks in certain things, you may see some green peak, which is magnesium, you may see a yellow peak, which is sodium, you may see a red peak, which is calcium. Those colours do not translate visually. That is only on a spectrum, and you need a diffraction grating in order to see that. What is more important is the fact that a meteor's velocity has a massive impact on where it will begin to burn up. Perseids are very fast, so because they've got more kinetic energy, when they hit Earth's atmosphere, they start to ablate higher up in the atmosphere. And that energy actually is exciting the molecules within our atmosphere, not the meteor. So the colours that you see are really the meteor ionizing air as it passes through the atmosphere. So higher up, you're going to get colour produced by oxygen. Lower down in the atmosphere, you're going to get oxygen and nitrogen. And you can see on this Perseid that's alongside this slide here, you've got green at one end going through red and then going to white again. And that is atmospheric. That is not meteor composition. So a lot of meteor showers will have a characteristic colour, and it's entirely to do with how fast those meteor particles are moving. If they're going slower, they might burn up in a different place. If they're going faster, they'll burn up in a different place. And it's the speed of the meteor that is characteristic, because that's linked to how fast its parent body was moving. And that is what gives you the colour. It's far more similar in colour to aurora, in fact, than it is to a spectroscope that you might have of fireworks. So please don't share that graphic if you see it. It's completely false. It's very misleading. Meteors are not fireworks, so you will not see those things. Now, in terms of meteor photography, I, for years, have used my Canon 1100Ds. For 16 years, I've been using my very trusty 1100Ds. Earlier this year, I actually bought myself a second-hand Sony A7. I have yet to photograph a meteor shower with it, so I'm looking forward to doing that and getting some less noisy, better resolution results with fewer hot pixels, because my cameras are dead at this point. But I will still be using the Canons because you can still get some good photographs with them. So basically, many meteors are quite faint and quite small, so they really don't get picked up very well on a wide angle lens. I've had very, very little success photographing meteors with a wide angle lens. I still find that on my 1100D that the free 18 to 55mm kit lens that I got with the camera is still the best for meteor photography. It blows all my other lenses out of the water. It's a lovely sweet spot between a big field of view but not so big that the meteors are lost in the background. So I just find it works really well. So yes, it's not the best quality lens on the market, but it does the job really well. Now that's a crop sensor camera. For my Sony A7, it's a full frame camera. So for this camera, I will be testing it with my 24 to 100mm lens, and I think the 24mm focal length is going to be something very similar to what I'm getting on my crop sensor with the 18. So I'm going to test that out, and if I need to zoom in a bit to just small field of view a little bit smaller, then I will do. But that should work really well. Whatever camera you have, you want to try and get a field of view that is covering about 45 degrees of sky, thereabouts, 40 degrees ish, because too wide a field of view, you're just not going to see the meteors. One thing that's quite important if you're going to be imaging for a long time is dew control, and you can of course buy dew heaters and you can get battery operated ones and they're all great, but the other thing that you can do is to cut the end off an old sock, tuck some hand warmers in, and then just replenish the hand warmers whenever you're changing your camera battery, and that will work really well at keeping the front of the lens just a little bit warmer and therefore less likely to fog up. If you don't have the ability to do any of that, just do stuff in your garden and have a hairdryer to hand to just blast them. Just a very quick blast with a hairdryer will get the dew to go away, but it will come back again quite quickly if you don't have a dew band, especially if the humidity is quite high, which tends to happen in the early hours before dawn when the dew all sinks down. Certainly does in my village anyway. Everything's always wet through when you're out at 2 in the morning, 3 in the morning, so do keep that in mind. Now, to focus the camera, you need to focus manually because the camera's not going to have a clue what to do. There's no infrared that can bounce off a star. So point at the brightest star you can see. We've got Vega, we've got Deneb, we've got Altair. They're all really good, like the Summer Triangle. They're all really good stars that you can focus on, and that will really work well. Use the live view screen, zoom in ×5 ×10, and just manually adjust the focus until the star will not be visible at all if it's massively out of focus, but as you change the focuser, the star will become a very blurry big blob, and then it'll become a smaller, less blurry blob, and eventually it'll become a point source, and that's what you're looking for. It's helpful to stick a bit of masking tape on at that point so that the focus stays, but you will have to check your focus through the night, especially if you're changing hand warmers and stuff. But that's how I focus, and it's one of those things, it's much easier to do with that field of view than it is on a wide angle, so it is really good. And some of the modern cameras have got focus assisting tools as well, so focus it manually, then you're good to go for the rest of the night. Your ISO conditions are going to be related to your local sky conditions. So we've got no moon this year, which is great, but you are going to have some form of light pollution unless you live right smack in the middle of a dark sky park, so you're going to have to adapt for that. So while it's great having a mirrorless camera that can do insane ISOs, I've already found out the hard way doing Milky Way photography that a higher ISO captures more of what you don't want as well as what you do, so you need to just balance that. So with my crop sensor camera, I always find 1600 is a good sweet spot. Any higher than that, you're introducing more noise. Now I still don't know what's going to work with my Sony yet, but I would think somewhere around ISO 2000 is perfectly adequate for this. And I always try to use a fairly low f-stop to let as many photons of light in as possible, and that will increase your chances of capturing faint meteors. I actually prefer to do shorter exposures for meteor photography for a number of reasons. I know some people do 30-second shots, but I prefer to do 10. And one of the reasons for that is that I just find it more chance of capturing an ionization trail. It means that if you've got a faint meteor, if you continue exposing for another 20 seconds, it can get lost in the background light. So I prefer shorter exposures. The downside of that is that every 10 seconds you've got to pause while the image is right into the memory card. So I always shoot in JPEG. And I know that for all astronomy purposes, you should be shooting in RAW. For meteor showers, I always shoot in JPEG. The write to card speed is faster, so therefore I've got less time getting lost by write to card losses. But also JPEGs take up less space. During the Perseids 2025, I took in excess of 20,000 photographs. If they were all RAW files, I would be swimming in backup hard drives. Like, there's so many pictures, and it's just a lot. You need big memory cards, big hard drives, you need a lot of processing power on your computer if you're making a time lapse out of it. So for meteor showers, just for the sheer volume of images I take every year, I always shoot in JPEG. And it also increases your chance of capturing the ionization cloud that I'll talk about in a second. So if you got all your focusing done in your camera settings, point about 40 degrees away from the radiant and about 50 degrees up, and choose the darkest direction of sky for you. So it may be the northern sky, it may be the southern, whichever way is the darkest, that's the best place to point your camera, because you're going to have more chance of capturing faint meteors. Think about foreground interest if you can. It's good to have something for scale, even if it's just a bit of a tree or a really well-known constellation. Like, I like to point my camera at the plough because it's a very recognizable group of stars, and I always get really nice meteors there. It's in a sweet spot away from the radiant, and it's a dark sky for us in that direction. So I actually really enjoy doing that. But just have a think about if there's anything you can put in the foreground to make it more interesting. Once you start imaging, just make sure you're using a shutter cable, the camera on continuous, and you can just lock the shutter cable and it will just take picture after picture after picture while you go away and sit down and do some visual. Just leave the camera alone and don't touch it. And the more still you leave the camera, the more things you can do afterwards with the images, which I'll come on to at the end. So this is a photograph of a meteor above the plough taken from an incredibly dark sky site in Wales at Solar Sphere a few years ago. Then the bottom right picture is a different meteor taken above the plough, but this time when there was an insanely bright moon. So I had to do lower ISO, etc. And in some ways, I actually prefer the right-hand picture because the foreground shows up better, because the other one was so dark you can barely see the tree. But either way, they're both very pretty Perseids. You've got a lovely green trail there and just absolutely gorgeous. Now, I keep talking about this ionization cloud. So what happens when the meteor ionizes the air? It can leave a smoke trail, essentially. So this is what that looks like. You can see it on the right there. There's like a wisp of smoke that slowly dissipates over time. If you do 30-second shots, the chances are you'll miss that completely. It'll have dissipated by the time you get to your next picture. So that's another reason I like to do shorter exposures. This again left an ionization trail. This was a real beauty of a meteor, even though there was a lot of moonlight, and it did leave a really nice smoke trail. Wasn't visible for as long because the moonlight got in the way. Those of you that have followed me online for a while may remember that that got me a Twitter ban. They said that it was pornographic. Crazy. So I was banned from Twitter for nearly 4 months because of that video, which is, obviously it was an AI decision, and I still have got absolutely no idea what about that video got me into trouble, but wild. Now, on the night of the Perseids a few years ago, I got this really nice fireball alongside Jupiter. This is actually a Kappa Cygnid. Trace of this meteor back, you can see in Stellarium that it goes to the radiant for the Kappa Cygnids. So it was a really nice fireball that just so happened to be right next to Jupiter. And you can see there's a lot of thin cloud there, and even through thin cloud, we're getting some really nice pictures. That's a close-up again of that beautiful green and orange meteor going through the plough. And this is a different meteor cropped, but again very green, going through red, going to white, because it's ionizing the air in our atmosphere, not the meteor itself. And sometimes you can get really lucky and get a meteor at the same time as aurora. This was during one of the big auroras in 2024, and I just so happened to see a bright meteor. But this one was taken during the Perseids a couple of years ago. We had aurora both nights around the peak of the Perseids, so having purple aurora alongside a green meteor was really quite special. So keep an eye on the aurora monitoring apps, because the sun has been doing some interesting things, and maybe we'll get lucky and get both again. So at the end of your imaging night, you may well have taken somewhere in the region of 4,000 pictures. I go from dusk till dawn, often with multiple cameras, so it's a lot of pictures to go through the next day. So the way that I do this, I don't use any tools for this. I use Fastone Image Viewer, fantastic piece of software that lets you zoom through your pictures full screen with no lag. And what I do is I just scroll through them in the morning, making a note of anything that I think is a meteor. And I also make sure that shooting on continuous will help you identify which are satellites. So meteor or satellite flare, meteors rarely span multiple frames, even with 10-second shots. Also, meteors are rarely symmetrical in the way that they get brighter and fade again. So what you can do is use Stellarium, look at the track of your meteor, see where it's bisecting, if it's a Kappa Cygnid, if it's a Perseid, or whether it's a sporadic. Doesn't seem to bisect any of the radiants. If you go on Stellarium, any showers that are active, you'll see the radiant on the map. If the shower isn't active, the radiant map won't be there. So you know, if there's nothing in the sky that seems to be connecting that meteor, it will be a sporadic. Now, this is a satellite flare. This is from the old days of iridium satellite flares. All these flaring iridiums have now gone. So if you see a bright satellite flare like this, it is not an iridium flare. They are no longer a thing, but there are many, many satellites up there that can flare this brightly, and they do so every single night. So you may well get something like this on your pictures, and you can see that it fades in, gets bright, and fades out in a very uniform way. Sometimes that bright bit smaller in the center, and that's because the satellite is tumbling, but you can see that it's fainter on the images either side of the photograph. So this particular thing here looks a little bit like a meteor in the top left, but if you play the video of the other frames, you can actually see faintly that that thing is tracking across the sky in 4 shots. So it's faint, but it's there. So if you're seeing a track in 2 or 3 pictures before the bright bit, it's definitely not a meteor. Meteors just don't behave like that. This is another one that, had I not actually been out there seeing it visually myself, I would have thought that this was a meteor, the bright one in the knot of the Milky Way, not the satellite above it. But again, If you look at this video, you can see that that fades in and then fades out again slowly. So that spans over about 5 images, and meteors just don't do that. So that's how you determine what might be a meteor and what might be a satellite. There will be a lot of satellites. The sky is full of them now. There's nothing we seem to be able to do about it. We've just got to live with it, and it's really frustrating and it's distracting, and I hate observing meteor showers and just being bombarded with satellite after satellite. It's really very, very distracting, and I hate it so much. But that's how you can figure those things out, and whether it's a meteor or a satellite. Now, you may well have only caught, out of your 3,000 or 4,000 pictures in a night, you may have caught between 8 and 10 Perseids on there. What are you going to do with all the rest of the images? Don't delete them, because there's quite a few things that you can do, particularly if your camera's been kept still. So the first thing you can do is get just the meteors and stack them. No alignment, just use a star trail software called Star Stacks. And in there are 11 Geminids, but you can do the same with Perseids if you want to. These kind of pictures that you see that claim to be a stack of meteor showers, they are composites. The Milky Way has been taken separately. Each of the meteors has been added in separately. The foreground will have been added in separately. So while they do look very striking, they're quite unnatural very often. And so many of them now are just totally fake. Like this one, for example, this was claimed to be a meteor shower, and they've basically used that starburst, like zooming the lens in and out, to try to give the illusion of a meteor radiant, and it's just utterly fake. So there's so much of that going on online now, so I just don't even try to do those. A lot of the time, if you look at those composites, the radiant isn't even in the right place, because as I showed you before, the radiant moves through the shower, and you see people creating this artificial radiant that's not in the right place for the meteor shower, and I find it frustrating because it's very misleading. The other thing you can do is get all of your pictures that you've taken and just turn it into a video, and that's always really interesting. You'll get aeroplanes, you'll get satellites, you'll get meteors and bats, and sometimes geese and sometimes moths, but you can get those really nice videos just doing that. The other thing you can do if your camera has been kept very still is to stack them using star stacks or sequator and create some beautiful star trails. So that's a star trail looking more or less at the pole, so you've got some circumpolar circular star trails, or if you're looking south at the celestial equator, you get these more straight kind of star trails. So you can do that with any of your cameras that have been kept very still, so you'll get a really striking star trails image even if you didn't get any meteors that night. The other thing you can do using star stacks is save the cumulative files and create a star trails time lapse. There's a tutorial on how to do that here on my YouTube channel, so that's always a really good crowd pleaser for your YouTube channel. You can also, if you've been pointing towards the Milky Way, if that's a good dark bit for you, you can take a few of those images and stack it and produce a nice Milky Way photograph. So that's really cool. There may not be any meteors in it, but it's a really nice Milky Way shot. This is a very old Milky Way time lapse, bearing in mind it doesn't fully get dark at this time of year, but if your camera again has been kept very still pointing at the Milky Way, you can just create a time lapse of the Milky Way moving through the night, which is another fun thing to do with the images. So there's quite a lot that you can do with those images, and how to stack using sequator for Milky Way and how to create star trails time lapses are already on my YouTube channel, so go and search those. I just want to finish up very quickly by talking about the Meteor cameras. We are part of the UK Meteor Network and the Global Meteor Network. We have these tiny cameras powered either by a Raspberry Pi or on a Linux box. They are recording the sky 24/7, looking for meteors, and they do tons of amazing scientific analysis. They can do an all-night stack like this, where you can, during the Perseids, expect to get almost 400 meteors per camera. We have 4 cameras giving us almost full sky coverage, and each of them will get in the region of 350 to 400 meteors per night if there's no moon and it's a clear night. So they do these really awesome stacks like that. They also do the track stacks where the stars are stationary, and that helps you to see the radiant and the direction that all the Perseids are moving in. So the meteor networks will do this, but they're all monochrome images, and the primary purpose of the meteor network is to do science. It's very interesting. Like, I share a lot of stuff from our meteor cameras during a meteor shower, but I want to make it really clear that what the meteor cameras are doing is capturing fainter things that you just will not see. So one of my brighter meteors on my digital SLR on the top left there, this is the same meteor caught on the meteor cameras, and it looks like a big meaty fireball. And all the meteors are much, much brighter on the meteor cameras. So if you see me sharing an all sky stack or an all night stack, I'm in no way trying to imply that that is what you will see visually, because you just will not. These are seeing things that are way fainter. But once they've captured these images, they are doing some amazing science. They're looking at trajectories, they're solving trajectories, looking at parent bodies, looking at meteor flux so that NASA know whether it's safe to launch spacecraft or not. There's a lot of amazing work that the meteor cameras are doing, and I love being a part of that project. But the meteor cameras are there to do science. They are not there to produce colour, high-res photographs. That's not their purpose. We're using a £9 monochrome CCTV camera in those things. So they're not there to give you great pictures. So we do still need digital SLR mirrorless photographs at high res that are in color. That is perfectly possible to do even with very basic digital SLRs or bridge cameras. And actually, even some of the modern phones, if you've got an iPhone, the Nightcap app will let you photograph a meteor shower, for example. So you can do this with pretty much any camera that you have these days. It's so much easier and accessible now to photograph a meteor shower. So do keep that in mind. We do still need better resolution pictures. So if you do see a fireball, report that. There's a fireball reporting tool on the SPA website. Submit your observations, like how many meteors did you see or how many didn't you see, because a no-show is just as important. It helps to model the debris field. If there's a night where there was just no meteors when you was expecting it, that's just as important as a sky full of meteors. So report those observations and your meteor counts to the SPA. My husband Mark is the section director for the meteor section of the SPA, and you can also submit that stuff to the BAA. Especially, we're always looking for good meteor photographs as well to go into Pop Astro Journal and the BAA journal, so please do submit those. This is the website popastro.com/meteor, where you'll find out loads of information about meteor showers and the prospects for upcoming showers through the year. And you can email my husband meteor@popastro.com.
So there we have it. That's my guide to both of those events. Very best of luck. Remember, with regards to the sun, always safety first. And if in doubt, just don't use the equipment if you think there may be a hole in your solar filter or your eclipse glasses are damaged in any way. Just don't take the chance with your eyes. It's really not worth it. So good luck with that. Let's hope we get clear skies. And the Perseids, as I said, it doesn't matter if you don't necessarily get a clear sky on the night of the peak, because you can very often get good activity the days before and after. I generally image the whole week of the Perseids, and that's awesome. There's always something going on. So yeah, I hope you found that really helpful. Let me know down below if you see any meteors or you get to see the eclipse this year. And yeah, I'm looking forward to hearing from you in the comments. So take care. Good luck on the 12th. Let's keep everything crossed for clear skies. See you in the next one. Bye for now.